Hello, friends. Welcome back to my channel. I hope you been doing pretty good and you got a chance to check out my other videos. Excuse the sound of my throat, but I've been a little bit under the weather. Um, today I'm gonna run you through two examples of data tables analysis. This is used for analysis and for sensitivity. So the first example has to do with a mortgage loan. I suspect that most of the people that run through Excel and all that can usually know how to calculate payments. I'm just gonna go over it real quick with you. Okay, so the first part is the rate. In this case, the rate is gonna be a 6%. Then we divide that by the number of payments in a year, which is 12. And then we input the number of payments in the life of which is 360. And then here is the present value, which is the amount that's going to be financed. It has a negative in there because that really represents in finance and outflow of money. So when you input that 180,000 financed over 30 years at 6%, you're gonna have a payment of 1,079.19. All right, so let's go ahead and verify that with our amortization schedule. And as you see here, that's the right amount. 1,079.19. Okay. So let me just point out another thing that a lot of people that I've seen doing these videos, calculating payments, they kind of leave out. And this is one thing that you might want to consider, or a lot of people just go for the default. But there is another thing you can attach into this, and that is the type. And the type is going to be here. Okay, let's look at that. Zero represents payment at the end of the month, which is default, mostly what everybody else does. And if you hit a 1 in there, it's not calculating. Okay, this is right here. When you punch that in, see, it comes here and it says end of period or beginning of period. So 0 represents at the end of the period, but if you put a 1 in there, it's a whole different payment. It goes down a little bit. There's a difference of, let's look at that. That's payment at the first of the month, and this is default that at the end of the month. There is a slight change in there. So that depends on somebody if they're really on time with their payments and all that. Okay, but the detail here is going to be that we're going to be looking at this. Okay, so I got the table more or less set up. I didn't want to waste time and putting in the percentages, and that you can do as any way you like. You can set up your columns and your rows. And in this case, I got percentage here going down. I got them changing at 1% all the way to 12%, and then I got from 5 to 30 years. Okay, so what you do is and then this number, you say equal to the payment. And in this case, you see the corresponding 1,079.19. Okay, so we take it, we highlight the whole area, and then we go here, data, and we hit what if, and then we say data table. Okay, so you're gonna get this little dialog box. Okay, so the row input cells, it's talking about this here. So here we got 30 corresponds to this one. And this is the columns, is percentages. So we're gonna hit this because that corresponds to that. And there it is. I'm just gonna make it a little bit clean it up for you. Okay. All right. So as you see here, I try to always incorporate the same percent that I have in the calculation to make sure that the table ran right. So as you see here, the 1,079 is reflected here at 30 years and 6%. That's it right there. So now here you can do the calculations in whichever way you want, or look at it if you let's say you say, well, I want to pay it off in 15 years at 6%. What is my payment going to be? 1,518.94. That's not including taxes and escrow and all that other stuff, but this is like a basic, what's your mortgage going to be. Let's say you do 5% at 15 years, that's 1,400. Of course, if you pump it up to 30, your payment is going to go down. Interest expense is going to go up. So, and that's at 4%. Of course, 12% is going to be big. So, that's the basic way of doing a data table analysis. And you can make this as big and as more, detail as you like. But this is just a rough, sensitivity analysis of percent over years. That way you can, look at it more from, bird's eye view. Because of course, loan amortization schedules, you would have to pump in different, different percentages and all that to be able to really do analysis. But this is much easier because at one glance you can look. What is if it's 8% at 20 years or 25 years or 4% at 30 years? So this is a very good way of doing any kind of sensitivity analysis. Okay, so let me run you through now a second analysis. In this case, I have we're trying to look at the price of gasoline if you're pumping gas in Japan. And of course, it's a different scale because in United States, of course, we use dollars. Here they use yen. And also it's not a gallon of gas, it's a liter of gasoline. All right. So, but if you're an American and you're driving in Japan, you want to make sure you understand that what type of money or what amount of money is coming out of your pocket as in relation to your American dollars. So this is a fairly straightforward calculation. We get this from the Microsoft data type, and this is USD, Japanese yen. And at the moment right now, it's 130.68 yen, that's spot. Okay. And roughly, this is a number that you pump in from your point of view, because of course, you can have different prices, low end to like a high end. That happens everywhere in the States, everywhere. You got high price gasolines and you got high lower gasoline prices. So but let's say that I observed that this is the average price around. So 157 yen. The spot is 130.68. So we gotta do some kind of conversion here. So 1 US gallon is one. How much is that? How many liters in 1 gallon? So we do this conversion here that from Excel. We're taking that, we're converting that gallon in liters. There are 3.79 liters in 1 gallon. So now we're going to convert that. So we take that and we multiply it against the retail price of the gasoline. That gives us a number of 594.31. That still doesn't mean anything to us right now. So now we go here and then we convert that number by the spot price of the yen. We divide it, as you see here, this little calculation. So we get $4.55. So if I pump gas at the spot price of this 130.68 and the retail price is 157 yen, this is the corresponding amount in dollars. So it's a little bit pricier than the states, depending on which state you're in, because California or Alaska or Hawaii, I think is more expensive. But if you're in the southern states, it's probably cheaper. So, okay, so we have that number. So we say equals this number here. That's the calculation. I put a rounding function in there to round the number. So I have it here, and it's called Japanese retail gasoline prices expressed in US dollar analysis. So I put a range from 150 yen all the way to 158. You know, that's observable. The price, the spot price from 130 right now, it's sitting at 130.68, all the way up to 144. You can make that increment whichever way, like I told you before. At any point, I have it incrementing by 1. So, like I said before, so we highlight the whole table. We go to data, the what if analysis, and we go to data table. All right, so you get this little dialog box, and then we say what corresponds with the roll here. And the roll here is the yen, the gasoline yen, and the columns is this, the yen spot. And we say okay, and there it is. So here it is. So of course, if you're an American and you're driving here and you see a retail price, a retail price of 150 yen, and you know that the spot price at the moment is 144, this is how much it's going to cost you in conversion to US dollars. You're going to be paying $3.94 for that gas. On the high end, of course, it's 158, and the yen is relatively weak, or more expensive against the dollar. That gas is going to cost you an equivalent of $4.60. Like I said before, you can do these analysis of data tables because it gives you a bird's eye view, and you can look at different scenarios at one time. If the retail prices go up, if the retail prices go down, if the yen spot goes up or goes down, what's the equivalent price for you? And this is a sensitivity analysis here. So you got a scale from $3.94 all the way up to like 460. And that's a calculation that can be done on anything. In this case, it's done on this. So, right now I'm finishing up, but in the future I'm gonna come back and I'm gonna show you this, which is a VBA program that I did. It's the same table, but this is a way to be able to like show what better. In this case, we got 30 years at 6% corresponds to that. That's the number right there. You just touch and it'll go. So stay tuned for my next video, and I'm going to show you how to do that exact thing. Please, if you like this contents, if you find it helpful, please subscribe, share, and come back in for the future. Thank you very much.